This is Bunting with your Visual Functional Mathematics at Level 1, Section 2, Measuring. Today's lesson is Lesson 3 on length and perimeter, area and volume. We will cover the following topics: finding the perimeter of shapes, working out the length of an unknown side, finding the area of shapes, and calculating the volume of 3D shapes. The keywords and phrases include perimeter, area, length, width or breadth, volume, 2D or two-dimension, 3D or three-dimension, and formulas. As I usually say, these words are important. You will be using them and you need to be able to use them appropriately and to understand their meaning clearly. Let's start with length and perimeter. We'll be finding the perimeter of a shape. We'll be working out the length of any unknown sides that relate to the shape. The perimeter is the distance around the outside of the shape, like the running tracks of a sports field. To work out the perimeter of this square, just add up the lengths of all the sides. Why? Because it's a square, so all sides are equal. So the perimeter would be 3 plus 3 plus 3 plus 3, which is equal to 12, or 3 times 4, which is equal to 12. But do not forget the unit, because in this particular lesson, units are extremely important, so you need to be conscious and aware of the units you're using. Example, find the perimeter of the shape below. Now this is a little bit more complex shape. So all you need to do is just add up the length of all the 8 sides, but you must be careful not to miss a side. That is important. So if you have a pen and paper or something, draw it out and then label them A, B, C, D until you get all of them accounted for. Okay? So the perimeter of this shape will be equal to 5 centimeters plus 5 centimeters plus 4 centimeters plus 1 centimeter plus 4 centimeter plus 2 centimeter plus 3 centimeter plus 2 centimeter equals 26 centimeters. Let's look at our practice set 1. You'll find out that you have quite a few practice set questions in this particular lesson, because while it's not difficult, but you need to be able to digest every point we covered and every point we make so that you'll be able to apply it when you're taking an exam. So find the perimeter of each of the following shapes. You have a rectangle 5 centimeters by 4 centimeters, and then you have what we call a polygon because of the number of sides it has. Poly means many. And you have 3 by 3 by 4 by 6 by 7 centimeters all around. And that is your answer. Question 1A, 18 centimeters. 1B, 26 centimeters. Working out the length of an unknown side. If you're only given the length of some of the sides, you'll have to work out the rest before you can calculate the perimeter. Sometimes this is fairly simple, you see, because if you know your shapes, then you will know their characteristics. For example, in this case, the rectangle has 4 sides, but you're only given the length of 2 of them. But you can easily find the other length. Why? Because the rectangles, we know that, or we should know that, opposite sides are equal. So once you know that, use the measurement of one side on the opposite sides, and then you add them together. Here is another example. What is the perimeter of the shape below? The first shape is an L-shaped two-dimensional space. You need to work out the length of the top side of the shape before you can find the perimeter of the shape. The solution to the example is working out these unknown sides. You have on the left 5 centimeters, and then you have 2 centimeters on the inside, and then you have an extension of 4 centimeters, and then you have 3 centimeters and 6 centimeters. To work out the length you don't know, take away 4 centimeters from 6 centimeters. And that will give us 2 centimeters. The unknown top side must be 2 centimeters long. Now you can just work out the perimeter as usual. So it will be 6 centimeters plus 5 centimeters, and then at the top 2 centimeters plus 2 centimeters plus 4 centimeters plus 3 centimeters equals 22 centimeters. Again, be aware of the unit. We're talking about centimeters. Why? Because it's the perimeter we're measuring. Do these practice questions first, set 2, and familiarize yourself with the method of finding the size of the unknown side and then working out perimeters in different ways. You have question 1A and B, question 2A, B and C. And then you have question 3, which is a rectangle, and that is very straightforward. But it is in the form of a problem that you have to read and understand. Quentin is fitting a skirting board in his living room. A sketch of his living room is shown below. The door to the room is 0.7 meters wide and doesn't need skirting board attached to it. That is a catch. Calculate the length of the skirting board that Quentin needs to buy. How will you do it? Remember the catch of the door. And there is your answers. Question A, 24 meters, B, 44 meters. Question 2A, 24 centimeters. Question 2B, 28 centimeters. And you're given the length of the unknown size. And then question 3, 13.25 meters. Now when you're dealing with perimeter, you're dealing with just a clear, plain unit, meter, centimeter, and so on. Now let's look at area. Area is the size of the area within a 2D shape, like in a football field. Because I used to love football, and or a tennis court, or in your sitting room if you want to cover it with carpet. So how do you deal with it? You can find the area of shapes by counting. If you look at the diagram here and the example, you have a rectangular shape with square, and they are 1 centimeter all around. So the area of this block is 1 centimeter square. Note, I said 1 centimeter square. Okay, so what do? We just count the squares in the box. So to find the area of the rectangle on the right, there are 6 squares, and each square has sides 1 centimeter long. So the area of the shape is 6 centimeter squares. If you're dealing with area, the units will be something squared. For example, centimeter square, meter square, or millimeter square. Note how we write square when we're giving answers in squares. By the little 2 at the top right hand side of the unit. You can work out the area of rectangles by multiplying. You need to know the lengths of the sides, then just multiply them together. For example, the rectangle at the bottom here is 5 meters by 12 meters, so all you have to do is to multiply them. 12 meters times 5 meters is equal to 60. But when you're finding area, it is squared. So the answer you should write is 60 meter squared. That is that little 2 you're seeing by the side of the meter sign. Example 2. Sophie is buying a new carpet for her dining room. The room is 6 meters long and 5 meters wide. What area of carpet does she need to buy? The answer is 6 meters times 5 meters, which is equal to 30 meters squared. You could draw or sketch the room if it helps you. Always have your pen, your notebook, your calculator, your mathematical set when you're doing maths, because you never know when you're going to need them. Sometimes you need to split shapes up to find the area, as you can see here. We'll look at the example, but first, it is a bit trickier to find the area of a shape that isn't a rectangle, but you can sometimes do it by splitting the shape. First, split the shape into two rectangles and look at their dimension. Starting from the top, going right, 3 meters, and then you have 2 missing measurement, and then going down 3 meters, and then you have at the bottom 6 meters, and then on the left 6 meters. So, and if you look at the shape on the right, it's the same shape. You'll see that 3 meters, and then the right side is also 3 meters. Why? Because on the left side of the first diagram is 6 meters. And if you look at the bottom, the opposite side, you'll see that it's 3 meters, and they are rectangles, so opposite sides are equal. Right? So how do we find this area? The area of the top rectangle is 3 times 3, which is 9 meters square. And then the area of the bottom rectangle is 3 times 6, which is 18 meters square. So the total area is to add both answers together, equal to 27 meters squared. Do not forget your unit. If you write 27 meters and forget to put the square sign, the little 2, after the M, your answer will be wrong. It's as simple as that. Practice question set 3. Find the area of each of the shapes below. Don't forget to give the units. 1A is by counting in blocks of 1 meter squared. 1B is a simple multiplication of width times length. But 1C is to split the diagram into 2 rectangles, and then you find the missing bit. 1D is the same thing really. Okay, so get your pens, get your pencils, get your ruler, get your piece of paper, and don't hesitate to draw it out. Yeah? If you get a book with a grid line, that would be even better, because you can easily scale them. And that is your answer. Okay? A, 6 centimeters squared. B, 42 centimeters squared. C, 30 centimeters squared. And D, 32 centimeters squared. You can also use areas in calculations. Now we're getting deep into your exam type materials, but first let's look at the simple bits. Example 1. Thomas is painting 2 walls as shown below. One wall is 7 meters long and 3 meters high. The other is 6.5 meters long and 2 meters high. Each tin of paint will cover 12.5 meters squared. How many tins of paint does he need to buy? First of all, remember when we're talking about comparing figures, you have to make sure they're all in the same unit. Well, that applies a bit. Let's look at how we solve this problem. Solution to example 1. First, work out the area of each wall. Wall 1, 7 times 3 meters is equal to 21 meters squared. And then the area of wall 2 is 6.5 meters times 2 meters, which is equal to 13.5 meters. And then you add them together and you'll have 34 meters squared. Now work out how many tins of paint Thomas needs to cover the area. This is where you have to think outside the box. To do this, divide the total area of the wall by the areas that one tin will cover. 34 meters squared divided by 12.5 meters squared, you see the same units now, all squares, is equal to 2.7. Why didn't I say 2.7 meters square? because they are not asking you to give your answer in meters square. They're asking you to find out how many cans of paint he will need to buy. But to get that answer, you need to do some calculation, which you've done. Thomas can't buy 2.72 cans of paint, so he'll have to buy 3 tins. 2 tins of paint will not be enough, so you need to buy 3 tins of paint. You see now how you begin to understand and enjoy maths, yeah? Let's look at example 2. Christine is laying a patio in her backyard. The patio will be 4 meters long and 3 meters wide. The paving stone she'll use are 0.5 meters long and 0.5 meters wide. How many paving stones does Christine need to buy? If she buys too much, she'll waste money. If she doesn't buy enough, she will have to do without, and it will not be nice. Let's see what she does. You need to work out how many paving stones will fit into the area of the patio. So first calculate the area of the patio, which is 3 times 4 equals 12 meter square. Then calculate the area for 1 paving stone, which is 5 times 5, which is 0.25 meters square. Now divide the area of the patio by the area of 1 paving stone. That is 12 divided by 0.25, which is equal to 48 paving stones. Again, note that I didn't say 48 meters square because your answer shouldn't be in meters square. You want to know how many stones she has to buy. And you have practice question set 4. A social club is raising money to put gravel on the car park and path. It will cost £4.20p for each meter square that needs gravel. How much money does the social club need to raise? And those are your figures. Okay, for the car park and the path. And question 2. Emma is tiling a section of wall in her bathroom. The tiles are 10 centimeters by 10 centimeters. The section of wall she wants to tile is 120 centimeters across and 80 centimeters high. How many tiles will Emma need? And that is your answer. Question 1, the answer is in money, £693. And question 2, the answer is in tiles, 96 tiles. Check your answer. If you got your answer right, celebrate by patting yourself on the back. If you didn't, don't worry, you learn by your mistakes. Just find out where you went wrong. I suspect some of you will have the answers in square meters or square centimeters, and just correct your answers and learn from it. Let's look at volume. What is volume? We need to know what volume is, and we need to be able to calculate the volume of a shape by counting or by multiplying. Volume is how much 3D space something takes. Something you can lift up is in 3D. My phone is in 3D, even though it's very flat. Your car is in 3D. Okay? Your suitcase is in 3D. Your stereo is in 3D. The bottle you hold your drink in is in 3D, so you get my drift now. Sometimes you can calculate the volume of a shape by counting cubes, just like you did for area. And the only problem is in area you count squares, not cubes. The units of volume will be something cubed. For example, 3 centimeters cubed. Centimeters cubed or millimeters cubed or meters cubed, as the case might be. Look at this example. What is the volume of the shape below? That cube you can see on the right is 1 centimeter cube. That is all sides, the length, the width, and the height are all 1 centimeter. So 1 times 1 times 1 is 1. Now, the shape on the left is made up of 8 cubes. So each cube has a volume of 1 centimeter cubed. So the total size of the shape in volume is 8 centimeters cubed. You write cube by adding a 3 after the unit. Calculating volumes can also be done by multiplying, where you need to have the dimensions. You can work out the volume of shapes even if they aren't broken down into cubes. For some shapes, you just need to know the length, the width, and the height. Then, just multiply them together, as you can see at the bottom there. The flat sides of a cube are identical squares. So, the length is 2 centimeters, the width is 2 centimeters, the height is 2 centimeters. So the volume will be equal to the length times the width times the height. It doesn't matter which side you call length, but usually we use the side of the cube as the length and the front as the width, and the height obviously as the height. Okay? Right, so we multiply 2 by 2 by 2, which is equal to 8 centimeter what? Cubed. Yes, you're right. Well done. 8 centimeters cubed because you did 3 calculations. Example 2. Calculate the volume of the cuboid on the right. The name cuboid should give you a clue. So in this case, the length is 8 centimeters, the width is 2 centimeters, and the height is 4 centimeters. So the volume is equal to length times width times height. By the way, if you're confused about width, it's the breadth. Okay, that's what we used to call it when I was at school. That will tell you how old I am now anyway. So 8 centimeters times 2 centimeters times 4 centimeters equal to 64 centimeters, 64 centimeters cubed. Okay? Practice questions set 5. What are the volumes of the shapes below? You should know A, you should know B. All you need to do, use the square centimeters cube to count the number. Note that some of the cubes are hidden, but if you look at the proportion of the side of the cube, you can tell that just 2 cubes are missing, which you can count. On A, and on B likewise, yeah, it's 2 cubes you cannot count. I mean, that can easily be accounted for. Question 2. Calculate the volume of the shapes below. That's pretty straightforward. And question 3. Sarah has bought a sandpit for her daughter. The sandpit is 0.8 meter long, 0.8 meter wide, and 0.25 meter high. What volume of sand can it hold? Give your answer in meter cubed. And your answers are question 1A, 12 centimeters cubed, 1B, 10 centimeters cubed, question 2A, 24 centimeters cubed, 2B, 50 centimeters cubed, question 3, 0.16 meter cubed. Now, as I always tell you, make a note of what we've covered, what you've covered and you're happy with, and then compare it with mine, and then anything that is left out, you can go back and update yourself. Or if you come up with anything that I have left out, then that's okay. All you need to do is just check and make sure whatever you've come up with is relevant. because we all learn differently. So the lesson summary, or my lesson summary, is you have now covered the meaning of perimeter, how to find the perimeter of shapes, how to work out the length of an unknown side, how to find the area of a shape by counting squares. We know that volume is space occupied by a 3D shape. We know that sometimes you need to split shapes up to find their areas. We know how to calculate the volume of a shape by counting. We know how to calculate the volume of a 3D shape by multiplying. We know that the unit for area is squared, that is the little 2 by the side. We also know that the unit for volume is cubed, that is the little 3 on the side. And that is your lesson for this week. Now, I know we've covered quite a lot. We covered a lot. It's quite a reasonably long lesson. And what you need to do now is go back and read through. Make sure you answer all the test questions. Get your exercise books. In this case, get it with grid lines so that you're able to have the exercise book with the little square in it. I think when we were in infant school, that's the first writing books we started using, and it helps you when you're doing maths to put tens under tens, units under units, hundreds under hundreds. In this case, it will also help you to draw shapes that you need to calculate. Okay, so that's our lesson for today. Practice, practice, practice. Remember, this is level 1, and if you have an exam to pass, you have to pass it.